Hi everyone, in this video we are going to discuss about theorem number 16 from the geometry of circles. Here the theorem says the larger of two chords of a circle will be nearer to the center than the smaller chord. That means if we have two chords in a circle, the distance of the larger chord will be smaller than the distance of the smaller chord from the center. So the distance is measured from the center of the circle. The distance between the center and the larger chord will be smaller than the distance between the center and the smaller chord. Let's suppose we have a circle like this with the center at the point O, and we have a chord like this AB. This is the smaller chord. And also we have a larger chord which is the chord CD. So let's assume that CD is greater than AB. That means the length of CD is greater than the length of AB. Next I am going to draw a perpendicular from the center onto AB. Let's suppose the perpendicular landed on AB at point E, and similarly I drew a perpendicular from the center onto CD. Let's suppose that perpendicular landed at point F on CD. We have to prove that OE will be greater than OF when CD is greater than AB. Let's get started with the proof. Now for us to be able to do the proof, we have to do a little more construction here. What I am going to do, I am going to join the center with the points A, B, C and D. Now one thing you can clearly see that OA, OB, OC and OD, they all will be of equal length because that's the radius of this circle, right? Now let's suppose that angle AOB is equal to 2 times theta. So angle AOE and angle BOE, they will be equal to theta because these two little triangles here, triangle OAE and triangle OBE, they will be congruent triangles. So angle AOE and angle BOE, they will be equal to theta if the angle AOB is equal to 2 times theta. And similarly, if we consider the angle COD to be 2 times alpha, then the angle COF and the angle DOF, each of them will be equal to alpha. There again, those two triangles, the triangles OCF and the triangle ODF, they will be congruent triangles. Now if you are thinking why they will be congruent triangles, well, if you think about it, we have seen in a previous theorem that perpendicular drawn from the center onto a chord actually bisects the chord. So in this case, CF and DF, they will be equal, and then OF is a common side, and the angle OFC or OFD, each of them will be 90-degree angle. So those two are right triangles, and then using the SAS criteria, we can say that both triangles are congruent triangles. And because they are congruent triangles, their corresponding angles, the angle COF and the angle DOF, they will be equal. So each of them will be equal to alpha if we consider the angle COD to be 2 times alpha. Now because CD is larger than AB, can we say that the angle subtended by CD at the center, which is 2 times alpha, will be greater than the angle subtended by AB at the center, which is 2 times theta? So that's what I have noted here, that since CD is greater than AB, 2 times alpha will be greater than 2 times theta because we know larger chord subtends larger angle at the center. We have proved that already in a previous theorem. So now from here, can we say that then alpha will be greater than theta? If we simply divide both sides of this inequality by a positive 2, then we get alpha greater than theta. And now if you think about these two angles, right, the angle alpha or the angle theta, each of them is actually an acute angle because they are an angle of a right triangle, and also they are not the right angle. So definitely they are acute angles. So alpha is an acute angle and theta is also an acute angle. Now if we take cosine ratio of alpha and cosine of theta, then what will happen? Well, cosine of the larger angle will be less than the cosine of the smaller angle. So we can say that cosine of alpha will be less than cosine of theta. And can we replace cosine of alpha with the ratio of OF over OC? And also can we replace cosine of theta with the ratio of OE over OA? And also we have already discussed that OC and OA, they are of equal length because they are nothing but the radius of this circle. So OC and OA are equal. So now if we multiply both sides by this equal quantity, then we are going to be left with OF less than OE. And if we write it the other way, then we can say that OE is greater than OF. And that's exactly what we needed to prove. So we have been able to prove that the distance of the larger chord from the center is actually smaller than the distance of the smaller chord from the center. I hope the proof made sense. Thank you for watching. See you in the next video.